All right, video is for May 4th, day 23, I believe. We're dealing with the law of sines, which you've already done. And the law of sines states these ratios are equal. Now we're going to be given the triangle angle side side. That is a non-included angle and two other sides. It's going to be two options. Either the angle is going to be acute, so angle A is acute, or we're going to have an obtuse angle there. We'll first deal with the first choice here where angle A is acute. Once you have this angle side given to you, you're going to have to check a couple things because we can have no solution, one solution, or two solutions. First thing we're going to check is A, length of A, equal to B times the sine of A. If those two things are equal, then we have one solution. And it turns out that this would be a right triangle. Basically what's happened, the length of this side A is perfect. It's going to come straight down here and create a right triangle. The second choice, and we're always checking this A to be sine of A. A can be less than the sine of B, and that's going to give us no solution. And that's basically kind of how it's drawn here. It's not long enough. It won't hit that third side and not create a triangle. And the third choice would be that A is greater than this B sine A. And this is the case. It's going to give us either one or two solutions. So you're going to have to check now if this is the case, that A is greater than BA. You're going to check first, is A greater than or equal to B? If A is greater than or equal to B, we have one solution. Or A will be less than B, and that will give us two solutions. And I'll go through examples of these guys. Okay. So you need to get all this down, and it's kind of just a little pain in the neck to go through the checking. But now we'll do the obtuse angle case for A. Okay, if angle A is obtuse, it's a little easier to check. We don't have to do that A, B sine theta check. All we got to check is the measure, the length of A to the length of B, and it's either going to be less than or equal to B, or the other choice, of course, would be that A is greater than or equal to, not greater than or equal to, just greater than B. The top case will give us no solution. And the bottom case will only give us one solution. So there's no case here where we're going to get two solutions if you have an obtuse angle. You will either have one or no solutions. And that's all there is to the rules of checking it. So now let's take a look at a couple examples on how to check these. Okay, so here is a first example. We've got an acute angle, C is equal to 63. We know B is 9 and C is 12. Now notice the rules always dealt with AB instead of now we got B and C. But remember, you're going to check the side opposite the angle given. That's the easiest way to think about this. And compare it to the side that is not across from the angle times the sine of that angle. So if I check that, this of course stays 12. This is 8.02. That is greater than 8.02. All right. If that's greater than that, then I need to check again the length opposite the angle and compare it to the length that is not opposite the angle. Well, that is greater than that. So if you check these two, that tells me that I have one solution. So think about it. It's always checking the angle opposite the side opposite the angle that's given. In both cases, start off with that side always. First case, you got to check 9 times the sine of that angle. and then just over here checking the lengths together. Well, it's a pretty easy problem now that we know we have one solution. All we're going to do is set it up. So I am given the side 12 here and the angle opposite that 63. So 12 is to the sine of 63 as 9 is to the sine opposite there. So it's going to be the sine of B. And if I solve that for sine of B, that would be over here. So I would have to now take the 9 and divide it by 12 and multiply it by the sine of 63. And I do the inverse sine of both sides. That's going to give me 42. So if I have the angle here 42, I can easily find the measure of angle A because I know the measure of angle A plus the measure of angle B plus the measure of angle C is going to equal 180 degrees. Now I'm not going to go through all the painful work. I can just tell you the measure of angle A is equal to 75, and I'm sure you can find that. And we could easily find the length of angle A because now I got the same ratio. 12 is to the sine of 63 as the length A is to the sine of 75. So length A is going to equal 12 sine 75 divided by the sine of 63. So length A is equal to, what is it, 13. If you're not getting the same numbers, remember that your calculator needs to be in degree mode because we were given an angle of 63 degrees. Okay, second example, I've got the measure angle B is 30, A27, B22, so I went ahead and drew a right triangle here. Not a right triangle, I'm sorry, I went ahead and drew a triangle that has that, but I notice I'm giving a non-included angle and two sides, so that is my angle side, and that means I must check it. So what must I check? I must check the length of the side that is opposite the angle to the length of the side not opposite the angle times the sine of the angle. Okay, so that gives me 22, and if I do this, that should give me 13.5. And obviously that is less than that angle. Then I need to check the length of these two sides, starting off with the same one I started off with here, 22, and compare that to the 27. Obviously that is less than 27. The result of these two tells me that my triangle has two solutions. So it's pretty easy to check. Solution number one. First thing we're going to find, the only thing we can find is the measure angle A. So I'm going to find the measure angle A. Solution number two, I'm going to go ahead and find the measure angle A. All right, now how do you find the measure angle A? Just like we did in our last problem with one solution. I have no choice. It's the ratio of 22 to the sine of 30. And that's going to equal the length of side A to the sine of A. So I go ahead and solve this for the sine of A, which if I multiply that over, that means I'm going to have to divide by 22 and multiply by the sine of 30. And if I did that correctly, I got A to be 37.9. Okay, so the measure angle A is equal to 37.9. And then you can go through and find all the other missing sides by using the ratio here. The second solution is really easy to find. All you're going to do is take 180 and subtract that 37.9 from it. and that's going to give me 142.1, and that gives me the second solution here, 142.1. Once I have measure angle A, I can certainly put that back in and go ahead and find all the other sides and missing parts. So I went ahead and did that here just so you can check. The measure angle C, of course, you just add them up, subtract from 180. I got to be 4.9. And a length of side C here, it should be 3.8. You can check those out for yourself. I also did it over here. The measure of angle C for this case would equal 112.1, and length C is 40.8. You can go ahead and see if you can get those on your own also. Okay, third example, I've got the angle A is 110, so this is my obtuse angle case, and I got the side opposite that, so it'd be length A is 12, and length of side C is 18, so that would be angle B there. Remember, we don't have to compare the side opposite A, which would be 12, to the sine, or the other side times the sine of that angle 110. All we need to do is compare their two lengths. Always start on the left with the one that is opposite the angle, and we're going to compare that to the other side. Obviously, this is less than that, and if that is less, then I have no solution. And I just stop right there. If it were greater than or equal to, then I just go through my ratios of the law of sines, which is quite simple. All right, guys, that's all I got for you today.